Welcome to Sequence Activities under Project Schedule Management. So Sequence Activities is also under the Planning Process group. In this process, we try to sequence all the activities that you have already defined under Define Activity process. So Sequence Activity is all about constructing a logical sequence of activities to obtain the greatest efficiency in given all project constraints. So for example, maybe you have a constraint in your project, a resource is not available in a particular period of time. Then of course, sequence activities is all about you should reschedule your activities properly so that taking into all those constraints, you try to define what is the most efficient activity sequence that can be performed in order to achieve your project target. So, as all other processes, there are some inputs and tools and techniques that we could use in sequence activities and also outputs of this process. One of the main inputs would be, as usual, the scope baseline, which will give you the scope statement, the WBS and the WBS dictionary, and also the project activity list that we just completed in the previous process, the activity attributes. If you can remember, the activity attributes will contain the activity ID, the name, what is the activity, what is the predecessor activity for a particular activity, and what is the successor activity, what is the relationship, whether it's as a lead or a lag relationship. So this is very handy because the activity attributes would be one of the key inputs for this process to sequence the activity. The activity list, any assumption logs that we have derived, that we have come across when deriving the activities, and lesson learned already we have, and any risk register that will give you any risk that we have highlighted when we define the activities. Also, as an enterprise environment factor, any government regulations, any industry standards would be an input for this process. For example, if a government regulation is there before importing certain items that you have to take permissions from the government to import certain items for your project, then of course we'll have to first understand the government regulation process. So as when you're defining and sequencing your activities, that this will be used so that you sequence your activities such that taking approvals from the government regulators will be done prior to ordering the stuff for your project, so you can sequence your activities properly. Same goes to industrial standards. Maybe your industrial standards requires adherence to some quality control standards, so therefore you will have to understand the activities that is required to achieve the quality control standards prior to sequencing your activities, so that you can sequence your project activities such that you achieve your quality control standards or industrial quality control standards. And also organization process assets such as any policies, procedures and guidelines that is there to on sequencing your activities which is used in your organization, and also any templates that you used in your organization for sequencing activities will be an input for this process. Now there are two main type of tools that we use in sequencing activities. One is the precision diagramming method, PDM, and also two other concepts are lead and lags. So before coming to precision diagramming method, I would like to take you to some activity relationships. So we will need to understand activity relationships in more greater detail before coming into precedence diagramming method. So in project management, we talked about 4 types of activity relationships. One is the finish to start relationship, which is most commonly used. For example, to start printing a user manual, maybe you're in a software development project, and if you want to start printing the user manual, you will have to first finish drafting the user manual. So that's an example for this. Then again, there is a relationship called start to start relationship. For example, to start producing a research report, first you have to start collecting research data. So when you start collecting research data, then only you can start producing a report, maybe intermediate report or a partially completed report. But to start producing a report, you will have to first start collecting research data. Then there's another relationship called finish to finish relationship. To call migration a finish, you have to first finish the data transfer. To call the migration a finish, first you have to call the data transfer, you have to finish the data transfer. And also there's a relationship such as a start to finish relationship, which in case sometimes is very rarely used. To vendor to define as job is finished, first you have to start the server installation. Let's take another example for better clarity. Again, finish to start. For example, in a real life example, you have to finish opening the can to start drinking soft drink. A start to start example, you have to start creating a presentation to start a voice recording on a presentation. A finish to finish example, you have to complete a pilot study. You have to finish completing the pilot study to complete the feedback collection process. A start to finish example, maybe your employee of the previous shift has to finish to start the second shift of your employee. Here are some examples given in the PMBOK. Again, finish to start. An award ceremony, a success activity. Award ceremony to start cannot start until the race or the predecessor activity has finished. So an award ceremony to start, you have to finish the race first. Finish to finish relationship from the PMBOK. To write a document, predecessor activity is required to finish before editing the document. Successor activity can finish. A start to start example in the PMBOK, leveling a concrete, the successor activity cannot begin. To start leveling a concrete, first you have to pour the concrete. So you have to start pouring the concrete first into your slab if you want to start leveling your concrete. So first you have to start pouring your foundation, and then only you have to start leveling your concrete. A start to finish example, the first security guard shift, the successor cannot finish until the second security guard starts. Also, there is a concept of lead and lag. What is lead? Lead is the amount of time that a successor activity can be advanced with respect to the predecessor activity. Lead is where the successor activity can be advanced in respect to predecessor activity, and a lag on the other way around, where the successor activity can be delayed in respect to predecessor activity. So for example, write a manual and proofreading the manual. So writing a manual have to start the proofreading manual. But then there could be a lead time, because you can write a manual, say maybe your user manual in a software project. You may have to finish at least 30% writing the user manual to start proofreading what you have written already. So there can be a lead time here for the second activity. And also there can be a lag time for the successor activity for printing the manual. So there can be, after the proofreading, there can be a lag time before you start printing the manual. So I hope you got the four relationships and also the concept of lead and lag. So once you have understood that, and once you have defined your activities in your previous process, and once you have understood the relationships between your successor activities and predecessor activities, and the lead and the lag time relationships, you will be able to draw a precedence diagram which all your activities A, C, D, B, E, F, and you can start and the finish of your project, and you might be able to start map the activities sequence. Also, it's important to understand three more concepts under activity sequence. These are the float. There can be something called a free float. Free float is a time an activity can be delayed without delaying the early start of a successor activity. Free float is a time of the activity that you can delay without delaying the start date, the early start date of the successor activity. And the total float is a time of an activity. Time of an activity can be delayed without delaying the project end date. A time of activity can be delayed without delaying the project end date. And the project float is where the entire project, the time of a project, can be delayed without delaying external imposed project completion dates for your customer. Maybe, for example, you have promised a customer to deliver a system in the third quarter in September, by September 30th, but then putting all your activities in together and calculating your time, maybe you are finishing your time by end of August, but you are keeping another one more month slack time, and before committing to your customer as 30th September. So that 1 month project float would be, the project can be delayed without delaying the externally imposed project completion date to your customer. Let's take an example for more clarity. Look at this example. There are activities A, B, C, D, E, and F. And there's activity G and activity H. So activity G and between activity H, there is a free float of 5 days. So activity G can be delayed for 5 days before. Activity G can be delayed for 5 days before getting affected the early start date of activity H. So there is a free float of 5 days. And also activity H can be delayed for about 3 days without affecting the activity F, which is depending on the output of activity H. Together with, if activity H can be delayed further for 3 days, then totally activity G can be delayed for 3 plus 5 days, 3 days, for 8 days. So therefore G's free float would be 5 days. I'm sorry, G's free float could be 5 days. The number of days that G can be delayed without affecting H earliest start date. And G's total float could be 8 days, because if H can be delayed also for 3 days, and the total float available for G will be 5 and 3 days together. But however, for H activity alone, Total free float will be 3 days, because if you delay more than 3 days, the early start date of F will be start getting affected. And also this will be the total float of H2, because beyond that the activity H cannot be delayed. So I hope you got an understanding of the concept of free float and the total float and the project float, the project slide. So in project management, there is a notation for each process. Usually an activity is denoted by a rectangular box where the earliest start date and the earliest finish date, the latest start date and the latest finish date is denoted in the four corners. So the float is between the difference between earliest start date and the latest start date, or it should be equal to earliest finish date and the latest finish date. Let's take an example. The following illustration is a project network activity, activity D, and it includes some information about activity D. So the earliest start date is 21 and the earliest finish date is 23. The duration of the activity is denoted here. The duration is 3 days for activity D. So you start on the 21st of the month and then 3 days for this, including the 21st day. It will finish on 23rd of a particular month. Earliest finish date, the latest start date is 37, day number 37, and 3 days for the activity D to perform, and the latest finish date will be day number 39. So given information provided, what is the total float in activity D would be the difference, either the difference between this and this, or the difference between the latest start date and the latest finish date, which will be 16 days. So the gap between these two is 16 days and this gap between these two is 16 days. So the total float for activity D is 16 days. Hope you got that example.